Hello everyone, here in this session we are going to discuss the implementation of merge sort. In C language, we are going to implement merge sort. So we are having an initial list. This is our initial list and this is unsorted. This is unsorted list. Our target is to sort this list, right? So in order to sort this list, we are going to do some task. That is, we need to write main function code. After this, we have to work something over sort function, and then we need to do some function on merging. So basically, we need to write some part of code in main function. Thereafter, we need to write some part in sort function, and thereafter we need to merge them as we have discussed in the lecture. Lecture is also available in our data structures playlist. You can watch it. Now, let's start from the main function onwards. If you can see here, int main I is a variable list before sorting. You already have a list that is nothing but a one-dimensional array. Now, using this simple for loop condition, as you know very well, we can simply print it, but this order is unsorted. Now we need to sort it. So we are going to call a function, and this is a sort. Two parameters are here. First one is 0 and other one is max. It means that if you are going to see the sort function, you can take the following example. Let's say this is an array, and here we are having 0 indexing, that is this, and max means the last indexing of it. So if we are having, let's say, 10 elements, it would be, let's say, 5, 7, 1, 3, 21, 31, right? Let's say 15. It can be anything, 0, 1, 2, 3. Let's say here we are having 8. So 1, 2, 3, 4, 5, 6, 7, 8, and let's say 9, and let's say 10. So we are having 10 elements here, 0 to 9. Max is nothing but 9 here, right? So if low is less than high, right now the low is nothing but the first indexing, and high is nothing but the last indexing. So definitely low is less than high. Definitely it is true here because 0 is less than 9, right? So mid, we need to calculate mid. That is low plus high divided by 2. What is low? 0 plus 9 divided by 2. That is nothing but 4.5. So what we can take in this case? We can take a floor value, let's say, a seal value, let's say, or we can take floor value. So 0 to 4 means total 5 elements, and then 5 to 9 means again 5 elements, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I am taking? I am taking seal value of 0 plus 9 divided by 2. Now, just focus here. The array is exactly divided like 0 to 4. 0, 1, 2, 3, 4. That is up into this part. So this will become mid. That is 4 because we have assigned that value to mid. And this is nothing but this is mid plus 1. That is this 5, right? So sort. We need to sort low to mid. It means that we need to sort this smaller part, this sub problem of this particular bigger problem, and we need to sort this problem, right? And sort mid plus 1. Mid plus 1 means this one, and high. And thereafter, after sorting them, we need to use merging, and we are going to merge low, mid, and high. So similarly, we can again divide it. Here this time 0 is low, this mid will become high, because if we specifically talk about this array, it would be like 5, 7, 1, 8, 3. So 0, 1, 2, 3, 4. So 0 plus 4 divided by 2. You can take floor value. Depends. You can take floor values, right? Rather than seal value, you can take floor values. So 0 plus 4 divided by 2, that is 2. So 0 to 2, it would be your one array. In 3 to 4, it would be your next array. So this 0 will become low. This second indexing will be like mid. This 3 indexing would be mid plus 1. And this would be, let's say, high. And we need to divide it till our problem becomes smallest subproblem. So, right, we need to do it. Thereafter, we need to focus on the merging int low, int mid, and int high. I hope you know about it. Now, for loop, we are using the concept of for loop. L1 equals to low, L2 equals to mid plus 1. It means that if this is our bigger array, then this part is L1, that is low, and L2 is mid plus 1. It means that this is L2, left 1 and left 2. I equals to low. Initially, I am assigning I equals to low. It means that if the indexing is 0, I will have 0. L1 is less than mid. This L1, this part is mid, right? And L2 is less than high. This part is high. This part is low. So if L1 is less than equals to mid, obviously L1 is less than equals to mid. It is true. And L2 is less than equals to high. L2 is less than equals to high. This is also true. Then what we need to do? We need to compare A of L1 with A of L2. This particular value with this particular value. So let's say here we are having 10 and here we are having 2. So I am going to compare 10 is less than or equals to 2 or not. The meaning of this, if A of L1 is less than equals to A of L2, right? If it is so, if it is true, what I am assigning B of I equals to A L1 plus plus, right? So if it is true, then B of I is going to assign A of L1 and thereafter plus plus. So I am going to assign this B of I. What I am going to assign B of I? A of L1. So A of L1, that is 10 and L1 plus plus. So L1 plus plus would be here. If it is not true, then B of I equals to A L2 and it is plus plus. So if it is lesser than, but here it is not lesser than, because 10 is not lesser than equals to 2. 10 is bigger than that. That is why B of I equals to A of L2 plus plus. In this case, if you are going to see A of L1 is lesser than equals to 2, no, it is not so. It is not so. So B of I will be A of L2 plus plus. So what we need to do? We need to swap them. 2 will be in the new array. It would be like 2 here, and I need to increment this part. Right. Again, I am going to compare A of L1, that is this particular element 10 with the next element here. Let's say here, this time it is 15. So what I will do, I will place this 10 into my next array, that is B, that is 10. And thereafter A L1 plus plus, I will increment that pointer. Again, I will compare this one and this one. Whatever is small will be placed here in this array, and that particular pointer will increment. If it is smaller, it will increment. We need to do this till we traverse this left array completely or right array completely. It means that we need to traverse both the array completely. It is going to repeat every time. It is going to compare, and the lesser element would be put into the array, that is B, one by one, right? So this is, we are merging them by dividing the problem into equal to halves, right? While L1 is less than equals to mid, because many times what will happen that while L1 is less than equals to mid, so definitely L1 and mid, L1 is less than equals to mid. So B of I plus plus equals to A of L1 plus plus. B of I plus plus equals to A of L1 plus plus. So it means that we are going to put first element here, thereafter the next element would be here, thereafter the next element would be here. We need to increment that. And while L2 is lesser than equals to high, we need to increment L2 with correspondence to B. If we are picking up the smallest element from left one array, that is this array, we need to increment this pointer, and we need to increment this pointer with respect to array B. If we are picking the smallest element from right one, then we need to increment the bi plus plus with respect to 8 L2 plus plus. For I equals to low, I less than equals to high, I plus plus. We need to do it till we cover all the elements from low to high. And one by one, we can after that assign all the elements to original array, that is AI. So if it is so, then we can again come back here and list after sorting. That is sorted list. Again, we have placed in AI. You know how? Using this for loop. Using this for loop, what we are doing? We are what we are doing? We are placing sorted elements. We are placing sorted elements into array AI. So we can print them using this simple for loop, right? So I hope this concept is clear. In all the cases, whether it is best case, whether it is average case, and whether it is worst case, in all these three cases, the time complexity would be order of n log n. You know why? Because we are dividing the complete array in equal to subproblems till the smallest subproblem, and thereafter we are comparing them and merging them. So we are reducing the problem every time with the half size, but we need to work on n elements. That is why n log n, right? Okay, if you are having any doubt, confusion, queries, feel free to ask. Have a very nice day. Jai Hind, Jai Bharat.